I'm going to run you through how to do the calculation for the design snow load for Newton High School. And so we have several of our information that we need, so make sure you go ahead and get those put in your engineering notebook. The variables that we need are here, so make sure you copy those down, and we'll go ahead and write down the formula. The design snow load is equal to 0.7 times the roof slope factor. The roof slope factor is how much pitch is in the roof, or how steep the roof is. That is multiplied by the exposure factor. The exposure factor is a number that has to do with how much exposure to the sun the roof is going to get, so it can try to start to estimate how much of that will melt off. We multiply the exposure factor times the thermal factor. The thermal factor is how much heat is escaping through the roof in your building based on the insulation materials that you have used. We multiply that by the importance factor of the building. The importance factor of the building is based on this table right here. So there are 4 categories, and you put this number in place for that importance factor based on which category your building falls under. So if we look at our table here where it defines each of those categories, we can see that a risk 1 category are things like agricultural buildings, temporary facilities, minor storage facilities. These are things that where people aren't typically going to be working in a whole lot. 3 are buildings that represent a substantial hazard to human life in the event that something fails in the structure of the building. And so we can see here, these are things like elementary schools, secondary schools, daycare facilities, and it says with an occupancy of greater than 250. If we look at importance factor risk category number 4, these are things like emergency treatment facilities, storm shelters, fire stations, that kind of thing. And so our importance factor for Newton High School, or our risk category, will be 3. So we're in the 3 based on this table, and this table was pulled directly from section 1604.5 of the International Building Code. And so our importance factor for this will be 1.1. Ground snow load is what we multiply importance factor by. Ground snow load is, again, a number that's estimated based on historical data for that area. And so I have printed off and copied a spot on the map for Newton. And so Newton is represented by this dot, which means we have a ground snow factor here of 20. And so that's the number we'll input for that. All right. For the purpose of this calculation, we are going to use the roof slope factor because we have a flat roof of 1. We're going to use an exposure factor of 1 because we're just going to be given that number because we're not saying that the placement of our building in relationship to the sun is either going to help or hurt the calculation. And the thermal factor, again, we're going to just leave that as 1 so it doesn't affect the rest of the calculation, because we're not sure if the thermal factor is going to help or hurt a whole lot at this point. And so we'll go ahead and just bring the numbers down. 0.7 Again, I said the slope factor, flat roof, is 1. The coefficient or the exposure factor is 1. The thermal factor is going to be 1. The importance factor of our building based on our risk category is 3, and so the factor we put in is 1.1 times our ground snow load, which is 20. So you multiply those numbers, 0.7 times 1.1 times 20, and we get a exposure factor, or excuse me, a design snow load calculation of 15.4. And that number should be pounds per square feet.